Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on October 29th, 2025, about 2 days ago. The striking idea is that this paper turns visual effect generation into an in-context learning problem using a single unified model that copies effects from a reference video, and with one-shot adaptation, it lifts effect fidelity score from 0.47 to 0.70, while raising content leakage score from 0.79 to 0.87. The paper is titled VFXMaster, Unlocking Dynamic Visual Effect Generation via In-Context Learning. And as we will see, the implications for scalable VFX creation are quite significant. Also, the authors shared the GitHub repo. You can access the implementation there. At the moment, it offers a brief placeholder README, indicating that code and resources are coming soon, with no releases or examples yet. Keep an eye on it for incoming code, models, and usage instructions. Alright, Figure 1 shows a single system copying cinematic effects from a reference video onto a target image while keeping the subject intact. The top rows illustrate in domain cases, where styles like grayscale or stylized motion transfer cleanly. The bottom rows present out-of-domain effects, which still track the reference dynamics without dragging over background content. This matters because effect attributes move, but identity and scene remain stable. Well, Figure 2 shows how the system learns from a reference example to apply the same dynamic effect to a target clip, which enables one unified model instead of many adapters. The left pipeline concatenates reference and target tokens and feeds them into diffusion transformer blocks. The grid at right visualizes a customized attention mask that passes effect attributes while blocking content leakage, meaning identities and scenes do not copy over. The lower right panel illustrates one-shot effect adaptation with concept-enhancing tokens, small learnable vectors that quickly boost tough out-of-domain cases. So Figure 4 compares out-of-domain results, meaning effects not seen during training. The top block shows that in-context conditioning already transfers motion and style while keeping the target identity intact. After one-shot adaptation, textures like dripping clothes rain, aquarium water, and Oni mask paint look sharper and more consistent across frames, which signals better effect fidelity with less content leakage. The side-by-side rows make the improvement visually clear because the adapted outputs track distinctive patterns without copying backgrounds. So, while Figure 4 focused on out-of-domain gains, Table 1 summarizes in-domain performance across many open VFX categories. The table shows lower fresh-at video distance, a perceptual video quality metric with an average near 1370. Dynamic degree, which scores how much motion the effect induces, reaches about 0.80 on average. The comprehensive VFX cons score, combining occurrence, fidelity, and content leakage, averages roughly 0.91. Across effects with complex motion, bold entries consistently favor the method, so quality and temporal coherence improve together. Wrapping up, 2 takeaways stand out. A single in-context model reliably transfers dynamic effects, while an attention mask prevents content leakage, and one-shot adaptation, meaning tiny concept tokens, sharply boosts out-of-domain fidelity. The broader implication is scalable, democratized VFX that adapts to new looks fast. I am Alex, thanks for listening to AI Research Roundup.